We're going to be solving a new type of equation in this section. An example of something we're going to be solving, this will be the first one that we do, is something like this. So we're going to have two equations, x plus 4y equals 3, 2x minus 3y is equal to 10. And how this is different is now we have an x and a y, and so we're going to be solving for two variables, whereas before we were only solving for one variable, which was the variable x or whatever in previous problems. And so there's going to be two main methods to solve these. And the first one that we're going to do, this is going to be substitution. In this method, I'll just do it to show you, maybe you guys like it. I think there's two methods, this one and elimination. I believe the other method's a lot more useful. This one's only good for certain situations, and this problem happens to be in that situation. So substitution is going to be kind of helpful when you have a variable that it only has a number 1 in front of it. So you see here, we got a 2, a 3, a 4, but this one has a 1 in front of it. When we have a 1 in front of one of our variables, then this method is going to work good. So let's talk about what we're doing here. First, let's label these equations. Let's call this one equation 1, this one equation 2. So substitution, sort of the main steps is pick either 1 or 2. And then pick a variable to solve for. And then also, once we pick the variable to solve for, plug this variable into the other equation. And then solve. So these are the 4 steps for substitution. So you see, pick either 1 or 2, and this step right here, pick a variable to solve for. A variable to solve for is very easy in this one. So to solve for x, all we have to do is subtract the 4y over, and then we'd have x equals 3 minus 4y. So you see, that's why substitution is easy when there's a 1 in front. Otherwise, say like for example in this one, say if we want to choose this equation and solve for x, we'd have to add the 3y over, and then divide everything by the 2 so x is alone, and then we get fractions, which would just be kind of annoying to work with. So let's use substitution for this one. For this first step right here, let's pick equation 1. So we're going to pick equation 1, x plus 4y is equal to 3. Now pick a variable to solve for. X is the easiest variable to solve for here. All we have to do is subtract 4y over, and we would have x is equal to 3 minus 4y. So you see, now we're done. We found what x is. X is this. Now it says plug this into the other equation. Okay, here's our other equation, 2x minus 3y is equal to 10. So now what we want to do is we want to take this and plug it into this equation. So we're going to have 2. Okay, but x is this piece. X is equal to 3 minus 4y. So instead of an x, we're going to put a 3 minus 4y. Then we have a minus 3y is equal to 10. So what we just did now we have an equation that we know how to solve for. There's just one variable, so we have to get the y on one side and everything else on the other side. So let's solve this equation for y. We'll distribute this 2. So we'll get 6 minus 8y is equal to, minus 3y is equal to 10. 6, now minus 8 minus 3 is minus 11 is equal to 10. Subtract the 6 over, and then divide by the minus 11. Okay, so now we have y, one of our answers. Y is equal to minus 4 over 11. So I guess there's one other, so this solve has a couple steps built into one. So we just did this. We plugged the variable into the other equation right here. That was this step. We found x. From this first one, we found that x was equal to this. Then we plugged that into our other equation. And then we solved. So we solved for y right here. But now what we're going to want to do is we also want to find x. So we're going to take this variable and choose either one of these equations and solve for x. Let's just choose the first one just because it has it's like the most simple equation. This one has numbers in front of everything. This one has a 1 right here, so it's just an easier equation to work with. So let's take this y, and now we're going to plug it into this first equation. X plus 4y equals 3. Now we're going to plug this y into here and solve for x. And now we're going to get the same answer if we choose the second equation as well. It doesn't matter which equation you choose to plug y into. Either one of these will work. So let's see what happens when we plug y into here. So we're going to get x plus 4 times minus 4 over 11 equals 3. So we're going to get x minus 16 over 11 is equal to 3. X is equal to 3 plus 16 over 11. That's going to be equal to 33 over 11 plus 16 over 11. So then we get x is equal to 49 over 11. Okay, so now we have our two answers. So you see x is 49 over 11 and y is minus 4 over 11. And that's it, so then we're done. Now let's do another example that has to do with elimination, or the other method of solving these equations. Okay, so that was substitution. This next elimination. Right, so let's just do an example with this one now. So another one we can do, let's draw another one out. Okay, so now elimination. So let's do, let's just write the steps out for this. So what we're gonna do, again, let's just build these equations. Here's like this the first one, here's the second one. So the first thing we're gonna do is just choose a variable x or y. So we're going to choose a variable to eliminate. Okay, again, there's no right or wrong choice. We could choose x or we could choose y, it doesn't matter. And so the goal now is we want to figure out how can we get the numbers in front of the chosen variable the same. So you see here we have an x and here's an x, there's a 3 and a 5. We want them to be the same, so we have to figure out how to manipulate these equations to make the number in front of this x the same or in this x the same. Or if we were going to choose y to eliminate, we would want to make sure the number in front of this y, here is a 2, the number in front of this y is a 3. We have to figure out a way to make those two numbers the same. So let's see, choose a variable to eliminate. Then we'll call that step match the coefficients. So again, a coefficient is just a number in front of the variable. So we want to make sure the coefficients match. Okay, and now add or subtract. The equations. So each situation is going to be different. Sometimes you'll want to add and sometimes you want to subtract, and we'll see when to choose what situation. And then, so those are basically the main three steps. The last one, let's call it solve again. At this point, once we get to this step, it's not too bad to continue. Okay, so here again, let's start with this first thing. Choose a variable to eliminate. Again, it doesn't really matter. Let's just choose y to eliminate. All right, so now we want to match the coefficients. So the coefficient in front of this y is a 2, the one in front of this one is a 3. So we'd figure out a way to match them. But what we can do is let's take this first equation, 3x plus 2y equals 7. And then let's multiply this equation by 3. And at the same time, let's take the second equation and we'll multiply everything by 2. So again, that's okay to do. We're just going to multiply everything by the same number, so nothing is changing. And so what does this give us? Well, we're going to have 3 times 3, so 9x. 3 times 2, so 6y. 3 times 7, 21. 2 times 5, 10. 2 times 3 is 6. And 2 times 2 is 4. So you see, we just did that. Now we have a 6 in front of this y and a 6 in front of this y. So now it says add or subtract. So what you see here, this method is called elimination because we want to eliminate a variable. And so in this step right here, we're going to want to subtract these two equations. So you see, if we subtract these two equations, we'd end up getting a 6 minus a 6. So the y would go away. So in this situation, we're going to want to choose subtraction. The only time we'd want to choose add, so say if this was a minus 6y, then if we added the two, the y would go away. So we want to choose the add or subtract just to make these variables go away. So in this situation, again, we want to subtract because we have a 6y here and a 6y here. So if we subtract these two equations, so we'll do that right now, we get 9 minus 10, which is minus x, 6y minus 6y, which is 0, and 21 minus 4, which is 17. So solving for x, we get x is equal to minus 17. Okay? And now, just like in the last one, we could pick either equations 1 or 2 and plug this in and then solve for the remaining variable. So let's just choose this first equation. 3x plus 2y is equal to 7. Let's put this in the box. Now let's plug minus 17 into here. So we're going to get 3 times minus 17 plus 2y is equal to 7. And so what's this? This is going to be 30 plus 21. So minus 51 plus 2y is equal to 7. Add the 51 over. So we're going to get 2y is equal to 58. Divide by the 2. And then we're going to get y is equal to 29. Okay, so now we have the two answers for this one. We get x is minus 17 and y is 29. All right, now let's do another example. We're gonna do just 2 more from this section. So far, this example and the last example, we had an answer. We get, in this situation, x is minus 17, y is equal to 29. So in this next example, we're gonna do something that doesn't have an answer. So we'll see what happens with, in that situation. So in this problem, let's do x plus y is equal to 2. 1/2 x plus 1/2 y. Sorry. 1/2 x plus 1/2 y is equal to 2. And, well, let's just use elimination for this one. So let's label these equations. Here's 1, here's 2. First, let's see what happens when, well, again, for elimination, we want to choose a variable to eliminate. Let's just choose x for whatever reason. No reason to choose that one over y. So we can make the numbers in front of this x. So this x is a 1, this x is a 1/2. So let's just take our first equation, x plus y is equal to 2. And now let's take our second equation, 1/2 x plus 1/2 y is equal to 2. But let's multiply that second equation by the number 2. So let's see what happens. The first one, we're not doing anything, so we just have x plus y is equal to 2. Now in the second one, 2 times 1/2, that's just x. 2 times 1/2 again, that's just y. 2 times 2 is 4. So here you might see something a little bit weird. So here we have x plus y is equal to 2. Here we also have x plus y, so the same exact thing is equal to 4, which sort of tells us that 2 is equal to 4, so that can't happen. So already we know that there's no solution. But let's say we want to continue anyway. We didn't notice that right off the bat. The whole goal of elimination was you chose your variable, we chose x, get the numbers in front of them the same, which we do now. This has a 1, this has a 1, and now add or subtract to eliminate that variable. We're going to, again, want to subtract in this situation because we'd have 1 minus 1. So let's subtract these two equations, see what happens. X minus x, that's 0. Y minus y, that's 0. 2 minus 4, that's minus 2. So you see, again, we have something that's weird too. We have 0 is equal to minus 2. That's clearly not true. And whenever you get into this situation, 0 is equal to a number, that just means no solution. Okay, so we have no solution for this problem. Okay, now the last one, there's going to be 3 scenarios. The first one, the first type of problems we have one solution. This type of problem, we have no solution. Now in this one, we'll see that we're going to have infinite solutions. So for the problem that we'll do to illustrate that, it'll be this one. So 5x minus 3y is equal to 2. 15x minus 9y is equal to 6. So again, let's use elimination. Let's take our first equation, just rewrite it again. Now let's take our second equation. And what we can see here is, let's take our first equation and multiply everything by 3. Because let's say if we want to choose the x's to match, we're going to choose that variable to eliminate. We can easily make this x a 15 if we just multiply it by a 3. So we can just multiply this whole entire top equation by a 3. Because then what that's going to do is we'll have 5 times 5, so that's 15x. 5 times minus 3, so minus 9y. And 3 times 2, that's 6. And on the bottom, we'll have 15x minus 9y is equal to 6. So now again, you might notice something kind of weird, that we have the same thing. 15x minus 9y is equal to 6. 15x minus 9y is equal to 6. Again, so if we go one step further, again, the whole point of elimination is to choose a variable to get rid of it. So we chose x, we wanted to make the numbers in front of these x's the same. We did that by multiplying this top one by a 3, everything by a 3, so nothing changes, everything's still okay. We end up getting this equation up here. So in order to eliminate the x's, we can subtract these two equations, because we would have 15x minus 15x, which is 0, and we would get rid of our x. So we're going to get 0, but then we have minus 9y minus a minus 9y, so again, another 0. And we're going to have 6 minus 6 is 0. So all we get is 0 is equal to 0. So this is our last scenario. Whenever we get something like this, 0 equals 0, this tells us we're going to have infinite solutions. But when we have infinite solutions, we have to go one step further. So when we have infinite solutions, you just pick either one of these eventual equations. Let's just pick this first one. Again, what I'm doing right now is only for the the infinite solutions situation. Okay, so when we have infinite solutions, we just pick either equation. You know, here's equation 1, here's equation 2. Let's just pick equation 1. And then we're going to pick a variable to solve for. Again, it doesn't matter. We could choose to solve for y, or we could choose to solve for x. Let's just choose to solve for x. So we'd add this 3y over, then divide both sides by the 5. Okay, so this is telling us a couple of things here. So notice that our answer is x, y, and so we can write our answer like an ordered pair, you know, like an x comma y. So in this situation, our x is going to be this, 2 plus 3y over 5. And then our y can be whatever it wants to be. And this is always going to be the situation. Say if we, you know, in this problem right here, we chose to solve for x, we get x is going to be this. Whichever we choose to solve for, how do we say this? So you see here we chose x is we solving for x. So we're going to have an x part over here, and the other part is just going to be the other letter. So let's also solve, so this is one way to represent the thing as infinite solutions. But like we said a second ago, when we chose one of our equations, we could have, instead of choosing to solve for x, we could have solved for y. So let's also solve for y to show you what another answer that's also correct would look like. So say right here instead on this side, let's solve for y instead. So here's solve for y, and then on this side here we solve for x. So if we're solving for y here, let's rewrite that equation. 5x minus 3y is equal to 2. Doing 2 steps in one, let's add this 3y over and subtract this 2 over. And then lastly, let's just divide by the 3. Okay, so then another way to write this one is x can be whatever it needs to be. Any number you want it, you could pick it in, plug it in here, and then y would have to be this number. So this answer and this answer mean exactly the same thing. So what they mean is just infinite solutions means because we can plug in infinite numbers for x. Any number you can think of, you can plug right here. But that number also has to go here into this equation. Same with this one. Any number you can think of for y has to go right, you can put that right here, like 31. But then 31 would have to go right here as well. And again, so infinite solutions happens when this happens. 0 is equal to 0.